This short video will take you through a step-by-step guide of how to calculate the sign test, probably the simplest of the non-parametric tests. You need to make sure that you've memorised this table, as it's very common to get exam questions asking you what test to use when. The sign test simply involves counting up the number of positive and negative signs. It's a test of difference used with a repeated measures or match pairs design when you have nominal data. So let's have a look at an example. So a fictitious study was conducted to discover if students change their attitudes towards the death penalty after watching the film The Green Mile. So the hypothesis is watching the film The Green Mile will influence students' attitudes to the death penalty. It's non-directional or two-tailed because it is fictional. There's no previous research to back this up. So all we do is we record whether participants were for or against the death penalty before they watched the film and whether or not their attitude had changed afterwards. So you can see participant 1 was for the death penalty. After the film, they were against the death penalty. So we've assigned that a minus sign. It doesn't really matter which signs you use as long as you're consistent with your approach. So participant 4 didn't change their mind, so they get a no change. And participant 10 was a bit of an anomaly. They went from being against the death penalty to being for it afterwards. I don't know whether they didn't like Tom Hanks or the little dancing mouse, but something upset them. So if we look at that, the sign that occurs the least frequency is the plus, and there is one plus sign. So in this case, S equals 1. That's all the calculation there is. It really is that simple. Now, in this case, because one participant didn't change their mind, they are omitted. So we leave them out. So our N value is 9. Now, remember, we're looking for a two-tailed test. So it's the second row, 0.05 and 9, and we get a critical value of 1. So therefore, we can reject the null hypotheses. Our result was statistically significant because if you look at the top, critical values of S for the sign test, S must be equal or less than the stated value to be significant, and it's equal. So that means most people did in fact change their opinion after watching the film The Green Mile. Let's have a look at another example, because sometimes we might use ordinal data or analyze it at a nominal level. So if we look at this example, a researcher wished to find out if participants had a more positive image of stats after they'd been taught an introductory course. So our hypotheses, participants will rate statistics more positively once they've been taught an introductory course. And this time we've done a one-tailed because previous research would suggest that that might happen. So you can see here we've got our before scores and our after. And then we've got our differences. So 5 take away 6 is -1, etc., etc. Now we leave out the scores with no change. So in this case, there was 5 that we're going to leave out. And you can see that we've got 1, 2, 3, 4, 5, 6, 7, 8 minus signs and 2 plus signs. So our calculated value of S in this case is going to be 2 because it's the least frequent sign. If we look it up on our critical value tables, our number of pairs of scores is 10. Remember, we started with 15, but 5 were omitted because there was no change. So the critical value for a one-tailed test at 5% is 1. Now, our calculated value of S was 2, so it's greater than that. So this time, our result was not statistically significant. So we have to accept our null hypotheses. Most people did not change their opinion after taking the introductory stats course.